We are live, and we are going to do the lesson for 8.4. For those of you who have been, you are algebra experts, and algebra is what you were good at, well, this is your time to shine. This is the most algebra-ish thing we do in this course. And of course, it does involve the new rules that we learned yesterday, our new 3 exciting log laws. And there, or actually, I guess there's 4, but mainly the 3. 1, 2, 3. Product law, quotient law, and power law. So these kind of, we assume that if you don't know them, that you can look them up very quickly. More importantly, we assume that you recognize when you can use them, and that's what this algebra is all about. So let's get started on example 1. So I would like to solve for x. All right, well right now x is kind of buried in a bracket in the argument of this log and the argument of that log. I kind of need this all to be one thing. So here's where we go. We know that we can combine these two using the quotient law. The log of something minus the log of something else, where the base is the same, can be combined into the log of one quotient. Then we're going to basically do something called anti-log both. That was supposed to be the word both. Both sides of the equation. Right? The logarithm of something is a function, just like square rooting is a function, just like squaring is a function, just like taking the sine or the cosine of something is a function. So I can do that. I can perform that function to both sides of the equation, and it doesn't change the fact that the equation, the left and right side, are still equal. So I'm going to anti-log both sides of the equation. So then x minus 2 over x is equal to 3. We've kind of had this conversation before, but if it was a provincial exam and you got to this point here and said, oh, I'm canceling logs on both sides of the equation, they're going to say, take off half a mark for communication error, because you're not really canceling. What you are doing, again, canceling is a specific act. Canceling means I divide a number by itself and they cancel, or I subtract a number from itself and it cancels. That's what canceling means. Mr. Favreau, who taught here for a very long number of years and retired, said, you know, I've trained myself over the years to not even use the word cancel. I hate it. It gets kids thinking you can just all willy-nilly make things go away in an equation when you're doing algebra. And he even said that, no, when a student says cancel, I ask, how did you do that? And they say, I canceled. He goes, oh, I'm sorry, I don't know what that means. What? You what? Are you a wizard? Where did you get this thing from? So yeah, canceling is something that means something specific to a mathematician. It means that you divided a number by itself, or you subtracted a value by itself, or added a number to its own opposite. Either way, that's the same as subtracting from itself. And you can call those things canceling if you like, but anti-logging both sides of an equation is not canceling, right? If you ever got away with this, if you had x squared equals 16 and we said solve that, so you said, oh, well, I did that, boy, we should have taken off a half mark there, because that's not really what canceling means. What you really did here was you square rooted both sides of an equation, right? That's what you did. That's how you got that. And of course, then you realized too that you had to have plus or minus. But you get the idea. You performed an operation to both sides of the equation. You didn't cancel nobody. Oh, that was supposed to erase that. Didn't work. Okay, let's see. There we go. Oh, it didn't work. Still didn't work. Okay, hang on. Let's just go old school erasing. There we go. Okay. So, can you handle this from there? Times both sides of the equation by x, minus x from both sides of the equation, and divide both sides of the equation by 2, and then maybe put it in the right order, and there you go. X is -1. And we should be able to verify. And I'm kind of sorry that this is the first example, but I get why we used it as the first example, because it's actually an easy example. But quick, let's do the verify. Log to the base 2 of x is -1, -1 minus 2. Do you see what's about to happen here? Minus log to the base 2 of -1 is equal to log to the base 2 of 3. And what do we conclude from this? Does the left side equal the right side? It most certainly does not. 2 as a base times itself a number of times we'll get to 3, right? 2 to the power of 1 makes 2, 2 to the power of 2 makes 4. So somewhere between 1 and 2, this answer here is somewhere between 1 and 2. It's 1 point something. What's this side? Let me simplify that. How many 2's do you multiply by itself to get to negative 3? There is no such number, right? 2 times 2 times 2, you can times 2 by itself any number of times. You're never going to get a negative. Remember that the argument of a log can't be negative. I'll write that again because it's such an important thing. The argument of a log. Is there an E after the U in argument? I honestly don't know. The argument of a log can't be negative. Feel free to make fun of my spelling if it's bad, but make sure you understand that idea. We have a name for this in math. When the algebra spits out an answer, but you know it can't possibly exist, begins with an E, what do you call that? Extraneous. No solution. I'm kind of sorry that the very first example is one that doesn't work, but maybe it's not a bad idea to kind of reinforce that. Oh yeah, you can do all kinds of fancy algebra steps, but if something doesn't exist, it doesn't exist, even if the algebra says so. Algebra is not perfect. Algebra is the most amazing tool we have to find unknown numbers in situations and solve for variables, but it does sometimes spit out answers that don't work. It's not flawless. Next, let's see if this one gives us a true answer. Okay. Log laws say that if the base is the same, and I have a log of this argument plus a log of that argument, that's like saying it's the log of the two arguments multiplied together. And I'm going to use extra brackets here. Now, do I need to do those extra brackets? Not really. But I kind of like that. It kind of keeps my world organized. Now what am I going to do? Can I take the anti-log of both sides? No, because this side's not a logarithm, right? So no, the way I did this one doesn't work. So for this one, I am going to now switch to an exponential equation. So let's see what this looks like as an exponential equation. 4 is the base, 2 is the exponent, and the answer is the argument. And there you go. Grade 11 algebra back to haunt you. 16 is equal to, let's expand that. That would be 11x minus x squared plus 66. That's a terrible looking 6. Let me fix that. 66 minus 6x. Somebody make sure I foiled that right. I think that's good. So let's move everything to the left-hand side, because remember, that's how you solve a quadratic equation. You move everything to one side, have 0 on the other, and then see if you can factor. And if you can factor, great. If you can't factor, you got a quadratic formula you could break out. But let's see, we're going to move x squared to this side. 11x minus 6x is 5x. Move that to the other side, it becomes minus 5x. And moving 66 to the other side makes it a minus. So I minus 66x from both sides, and I get negative 66 plus 16 is minus 50. All right. Does that factor? Yes, it does. Minus 10 and plus 5. So x is 10 and x is negative 5. Now, do both of those answers work? It's possible one of them is extraneous, right? If you plug in these numbers and you get a negative argument, right? Again, 4 times itself any number of times can't be a negative, so you know that one of them is wrong. But you know what? I think both of these work. Let's do a check. First, we'll check the 10. Does log to the base 4 of 11 minus 10 plus log to the base 4 of 10 plus 6 make 2? Well, 11 minus 10 is 1. And 10 plus 6 is 16. Hey, neither of those are negative arguments. And do those arguments work? How many 4's do you times together to make 1? In other words, 4 to the power of what is 1? 0. And 4 to the power of what is 16? How many 4's do you times together to get to 16? 2. Hey, that answer works. Let's check the other one now. Log to the base 4 of 11 minus negative 5. Think about that. 11 minus negative 5. I'll write it out. Plus log to the base 4 of, what's the other one again? Negative 5 plus 6. Does that equal 2? Yes, it does, because notice this is exactly the same thing we just did, but backwards. So yep, we know it works. Both are true. Two answers to that one. There are two numbers that x could be that make this a true statement. Now, let's just kind of back up before we move on and make sure you understand the two approaches that were different here. Why were my two approaches different? Why on this one did I anti-log both sides, and why on this one did I turn it into an exponential equation? And the difference is, well, this one was a logarithm on both sides of the equation. This one had a constant number that was not an argument of a log on one side of the equation. So that's the difference, and that's why I had to use two different approaches. Any questions on how I did that? Okay, well, we've hit a your turn. I'm going to go to my video here, and I'm going to pause it. So can everybody here give this one a try? I'll give you a couple minutes to play with it. See if you can figure out which of the two approaches it's going to be. You could probably tell just by looking at it which one it's going to be. And then get an answer, and then see if your answer is real or extraneous. And okay, so I'll pause the video, give this one a try. Pause your video and try it. Okay, anybody, yeah, we're recording again. Anybody not finished yet, please, and still want to keep going, please pause the video. I'll give you a hint though. This is like example 1. This one you are going to anti-log both sides eventually. But first, you have to use your log laws to make this all, to make it all better. So let's see. We are going to turn this coefficient into an exponent because log law 3 says we can. And then we're going to turn the subtraction into a divide. Because log law 2 says we can. And then we've hit the point where we're going to say, all right, I will take the anti-log of both sides of the equation. So there we go. Anti-log both sides of the equation, and now x squared over x plus 2 is equal to 2x minus 3. I multiply both sides of the equation by x plus 2, which is going to look like that. And then there we are again on grade 11 quadratic algebra. 2x times x is 2x squared. 2x times 2 is 4x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is negative 6. Double check, please, that I FOILed that correctly. I'm going to move this x squared to the other side so that I have 1x squared plus an x minus 6. Then I'm going to ask myself, I say self, can I factor that? I most certainly can. It's plus 3 and minus 2. So that gives me two answers, and I'm going to check to see if they're right. So I'm going to just move over to here. Just going to go. So x is equal to negative 3, and x is equal to positive 2. Are both of those numbers really answers? Let's check. We have to check. Can't just stop there. Okay, and you have to go back to the original equation. So negative 3, you know what, I can just stop. Clearly negative 3 doesn't work. It would make this argument negative. It would make that argument negative. It would even make this argument. All three arguments would be negative. X equals negative 3 is extraneous. And I just misspelled. I was going to make an O and a U at the same time. And they morphed them into one letter. Extraneous. So that's not a solution. But how about x equals 2? Well, if x equals 2, I have 2 times the log of 2 minus the log of x plus, oh, sorry, I know x is 2. Log of 2 plus 2 equals the log of 2 times 2 minus 3. So let's tidy that up. That's 2 times the log of 2 minus the log of 4 equals the log of 4 minus 3, which is the log of 1. And somebody might go, why don't you just make this log of 4 because you could make that 2 into an exponent? No, I'm doing a check, right? I'm doing a check. I don't want to use my log laws. I'm checking to see if I did my log laws right in the first place. So I'm just treating this like arithmetic. which of course means I got to reach for a calculator. Because hey, remember, notice this one doesn't have any base number, which means that you assume the base is what? Remember that from yesterday's assignment, or yesterday's lesson? If you don't have a base number, you know the base number is
10.
10. So this is 10. So this I can actually check with my calculator. So I'm going to break out the calculator. Come on, little bunny calculator. There you are. So here we go. Clear everything. And I'm going to check. So 2 times the log, where are you, log of 2. And then I'm going to close the bracket because it opened a bracket for me. Minus the log of 4. And close that and hit equals. So the left-hand side is 0. And what's the right-hand side? Well, actually, that one I do know. Log to the base 10 of 1 is like saying 10 to what power makes 1, and again, that's 0. So, yep, it works. Therefore, x is equal to 2 is my solution. Is that what people got? Nicely done, people who got that. Notice it takes an understanding of your log laws. It takes a mastery of grade 11 quadratic algebra, and you even have to kind of understand basic log calculations with a calculator. This is kind of big stuff. This is one of the tougher things we do in grade 12. Okay, so let's do another one now. I'll do this one with you. This one won't be a you try. We'll just work this together. Unless, of course, would you like to? You know what? Yeah, you know what? You can try it. So I'll pause the video again, and we'll let you try it again. Okay, so go give that one a try. Pause back on. Okay, so let's see. Let's take a look at this one. Hint, this time you kind of have to do the exponential way. How come? How come I can't anti-log both sides? Because of this guy right here, because of this 1. You see, that's not part of a log argument, so there's not going to be a log argument on all terms on both sides. So I am going to do some rearranging. So this is going to be the log to the base 6 of x plus 3 plus the log to the base 6 of x plus 4. Right? So I collect those two, and then I'll leave the 1 on this side for now. And now I'll collect those into one logarithm, one argument, and that's going to be, and a plus becomes a multiply. And now I'm going to switch to the exponential mode. 6 to the power of 1, because this is my exponent, this is my base, equals that argument. All right, once again, starting to get repetitive. We're in quadratics land. X squared plus 7x plus 12. I move the 6 to the other side. X squared plus 7x plus 6. And now what two numbers times to make 6 and add to make 7? 6 and 1. So x is equal to negative 6, x is equal to negative 1. Check them. If negative 6 is put into either of these, you get negative arguments. X equals negative 6 is extraneous. But how about the negative 1? Well, let's do the check on negative 1. It doesn't make either of these negative. Log to the base 6 of negative 1 plus 3 should equal 1 minus log to the base 6 of negative 1 plus 4. Now, that's going to be log to the base 6 of 2 is equal to 1 minus log to the base 6 of 3. Well, the last one I was able to kind of get my way through it using a calculator. This time, again, I'm going to need a calculator. I don't know what log. 6 times itself, how many times is 2? I don't know. Some decimal. So now, how do I figure that out? Last time I was able to use my calculator because we had base 10, right? I don't know. So how are we going to do that? Well, if you have the fancy calculator with the fancy can pick my own base, no problem. But I don't, so I'm going to have to come back. Where are you, bunny calculator? For those of you wondering why I call it a bunny, notice that my little, can you see that? The little icon's a bunny, and it's called Wabbit Emulator. Wabbit Emu. And it's probably illegal, but oh well. Teachers are no respecters of copyright. So here we go. 6 is my base, so that's going to be change of base log, or change of base law, the one that's not on the formula page. There. That should be a true statement. For those of you wondering where the heck I got that, scroll. Oh, no. You don't have to. Why did I think I had to change books? I don't have to change books. Just got to scroll back, go back, go back, go back to where you were. And we are here. There it is, right? Log to the base 2 of 7 is log 7 divided by log 2. That is my rule for change of base law. The one that they don't tell you on the formula sheet because they're mean. I don't know. Because again, they figure you can just figure that one out. Do you want me to run through how to figure that out again? How do you know that law works? Where does that law come from? How far down did I scroll? Oh wait, too far, right? Where are we? There we go. There we go, sorry. Okay, where does that come from? How do we know that this is that? Well, because look, log to the base 6 of 2. If I need a value for that, I'll call that x. That's like saying 6 to the x equals 2. And now take the log of both sides of the equation. Again, it's a function. I can do it to both sides of an equation. Then log laws say that my exponent becomes a coefficient, and that's where it comes from. X is equal to log to the base. Oh, hang on a sec. Did I just do this wrong? Log to the base 6 of 2 is log of 2 over log of 6. Whoops! Look at that. I actually did this wrong. 6 to the power of x is 2. So yeah. Oh yeah, I did. Whoops! I've got this upside down. My apologies, guys. This should be a 2. This should be a 2 and then a 6. I've got my log law backwards. My apologies. Nobody noticed that. Or else you noticed it and you were just too polite. You're very nice people, aren't you? There we go. I got that backwards. Good thing I took a second. See, I don't memorize things well. I have to figure them out. There we go. Now I punch buttons on the wabbit. Come here, you wascally wabbit. Log of 2, close that bracket, divided by log of 6, close that bracket, has to equal this rather gnarly decimal. I'll just jot out the first bit of it, 0.38685. 0.38685, blah, blah, blah. The other side, if it isn't the same gnarly decimal, I've done something wrong. There we go. So 1 minus log of 3, close brackets, divided by log of 6. Close bracket equals, and there it is. Same gnarly decimal point. You can see it. You can compare it on the screen. It's right. So -1 is a real answer. Okay? So there we go. Now you're probably thinking, well, does that mean we get a calculator on the next test? For that kind of question, yes, you do. You do. Okay? But we could put this kind of question on the part of the test where you don't get a calculator and just say, we don't care if you verify it. Because you can tell this one's extraneous just by logic, and then you could say that this one may be an answer. Okay? Next, solving exponential equations with different bases. So when the bases of exponents cannot be changed into the same base, we must use logarithms to solve the equation. So note, although we do not know the value of x, we can estimate it, right? Because again, 3 to the 1 is 3, 3 to the 2 is 9, so 8 is closer to 9, so it's about, we'll estimate it's around 1.9, right? So that's how we get an estimate, but to actually get a more accurate look at the answer, we take the logarithm of both sides, the way I just showed you. Oops, oh my word, come back, there we go. And then this exponent becomes a coefficient, and this is my change of base rule right here. X, then divide both sides of the equation by the log of 3. And then punch that in your calculator. So calculator, move over here. What is, clear, what is log of 8, close the bracket, divided by log of 3? Maybe everybody understands why I'm closing that bracket, right? Otherwise, it's going to think that I want the logarithm of 8 times another logarithm, or 8 divided by another logarithm, rather than just the log of 8, get that answer, and divide by the next log, right? Calculator's dumb. It only does exactly what you tell it. If it thinks you want to do that, it's going to go, okay, I'll do that. So there we go. So that's going to be, what did I get? 1.9 was a pretty good guess. 1.8927. And somebody probably is going to notice, hey, I don't see a repeating pattern there, and that's true, right? This is going to be for sure an irrational number. So if you ever wondered, where do irrationals come from? Well, remember, square root of 2 is irrational, right? Square root of anything that's not a perfect square. pi is irrational, e, which we've talked about a little, we'll talk about a lot more, is irrational. Well, logarithms lead to irrational numbers as well. Okay, so let's see, hang on a sec. I accidentally closed the chat. There we go. Okay, so any questions on how I got to that? All right. Now that we understand how to do this with something simple, let's do something a little more complicated. There we go. Solve the following equation for x. There is some number in the universe that when you take that number and minus 5 from it, and that's your exponent on 19, it's the same as if you took that number, doubled it, and added 1, and that's your exponent on 3. So there we go. How do we solve this thing? We would take the logarithm of both sides of the equation. This, again, is about the most hardcore algebra you are going to do this year. Oh, oops. Forgot my log. There. So step 1, take the logarithm of both sides of the equation. Step 2, and hang on a sec, I'm going to get the calculator to go away because it's kind of in my way here. And is everything good here? Yep, everything's good. Okay. Sorry, my screen's doing weird things. That's why I thought I better check to make sure I'm still recording. All right, what's the log law now? Log law 3 says that these two exponents can become coefficients, but careful, they're binomial coefficients. Now what? Now we have to collect the x's, and the x's are trapped inside of brackets, so we have to expand. So we're going to expand. This is x times the log of 19. Now the log of 19 is just some decimal. It's 1 point something, right? Because remember, log means base 10. 10 to the power of 1 would make 1, so log to the base 10 of 1 is, or sorry, log to the base 10 of 10 would be 1. Log to the base 10 of 100 would be 2. So this is 1.1 or 1.2 or something. But it's just a number. So what do you do when you multiply a bracket by a number? Well, it becomes a coefficient. So that's log 19x. So log 19 is a coefficient. Minus 5 times the log of 19. And again, that's some constant. It's 5 times 1.1 or 5 times 1.2 or something like that. And you might be thinking, well, why don't you actually get what this decimal is? Do you really think I'm going to do algebra with decimals? Pff, you don't know me very well. I'd much rather do algebra with logarithms. So this is now 2 log 3x. Do you get where I got that from? Let me get the highlighter out. I got that from taking this term times this factor. And remember, all of this is some number. Okay? Times x. So it's just a big coefficient. Plus 1 times the log of 3. Now, what are you doing normally when you're doing algebra? I know what you're thinking. You're thinking this looks like a mess. But this is grade 9 algebra. You have 2 terms that have an x in them and 2 constants. This is a constant. This is a constant. They're ugly constants, but one of the beautiful things about math, I've probably only said this 50 times since the course started, but the rules don't change because the numbers look ugly. I just collect my like terms. So I've got log 19 of x minus 2 log 3 of x equals log of 3 plus, because I add this on the other side, 5 log 19. Now what do I do? Well, I'm collecting my like terms. Now normally if this was like 5x minus 3x, I'd say, oh, it's 2x and get on with my life. But these two things are very complicated numbers, so I have a different strategy. I'm going to use a different tool in my toolbox to isolate x. I'm going to factor it. I'm going to factor that x out of here. And that's what it's going to give me. Whoa. So now I'm going to divide both sides of the equation by this bracket. And there we go. I've isolated for x. And there we go. And again, people who are good at algebra were like, this is cool. This works for me. And the people who thought, oh man, this course, too much trig, too much graphing. Can't we just do algebra again? You probably want the trig back now, don't you? Well, I need an answer for that. This is one constant. So I am going to punch buttons and get a number. So please try punching buttons with me and see how it goes. I'm going to bring up the rabbit again. If you don't have a calculator as fancy as this, it shouldn't matter. You should still be able to get the answer. Okay, let me move it over a bit. And let me clear that off. And okay, here we go. I need to open a bracket, right? I need the calculator to know that this add happens, and then we divide by this subtract. So I do need brackets. So open a bracket. No matter what kind of calculator you have, you need brackets. Oh, unless you got that fancy one that has an over button, so you can put in a big numerator and then hit that button and put in a big denominator, in which case, well, nice for you, but I don't have one like that. So log of 3, close that bracket, plus 5 times. On this calculator, I probably don't even need the times. It would know to multiply, but some calculators need it, so I'm going to punch it. Log of 19, close the bracket for that log, close the bracket for that numerator. There. The calculator now knows that numerator. Divided by, open a bracket for the denominator, the log of 19, close that bracket, minus 2 times the log of 3. Close that bracket, close the bracket for the denominator. Drum roll, please. There it is. That's the same number I got when I did these notes last year, because I'm looking at last year's notes. Very nice. It's 21.173 and change. And I would not make you check that, but you could. By all means, you can, with a calculator, say, okay, I'm going to store that in, store that in memory. I think I'll go to memory. I'll call that memory A. So there we go. So that's now in memory A. So when I go second function recall memory A, it's going to say, oh yeah, it's that 21.173. So now I'm going to say, okay, 19 to the power of, open a bracket, memory A minus 5, close brackets, equals 4.8 and change. Remember that number. 3 to the power of, open a bracket, 2 times that A number again, plus 1, close my bracket. Ta-da, the two sides are the same. I don't think we've ever made people do a check on this kind of a question, but you can. Certainly you have to have a calculator to do this part anyway, unless I get a question where, you know, I've seen the provincial exam has actually had questions like this where it says, to solve this, which of the following would be the correct calculation? And then they give you 4 choices that look like that, but oh, maybe there'll be a minus up there and a plus down there, or they'll have the 5 in the wrong place, or the 3 and the 19 will be switched. So we can test this stuff without a calculator if we really want to, but for the most part, these are calculator questions. Okay, let's do one more together, and then we'll call it a lesson. So here we go. Ready? Log to the, open bracket, 2 times 3 to the x is equal to log of 6 to the power of 3x minus 1. And they give you a little reminder that, yeah, don't forget, 2 times 3 to the x is not 6 to the x, right? Because BEDMAS says exponent happens before multiply, right? 2 times 3 squared is not 6 squared. It's 2 times 9, which is 18. Are we all cool with that? Okay, good. So that's why I make this all one thing. Now, what can we do with this? Well, we can split this up, right? The log of a multiply can split up into the log of an add. There's log law 1. While I'm at it, let's use log law 3. Everybody get how I went from that second step to that third step? In log rules, exponents become coefficients. And again, exponents become coefficients. Now, I tend to write this now. I'm going to rewrite this. To me, again, this log of 3 is a coefficient. I know that the x is the coefficient on the logarithm, but if I think of log of 3 as just a number, right? What is it? I don't know. 10 to what power makes 3? I don't know. 0.6? I don't know. Something like that. Okay, so I'm noticing in the chat somebody did not get the right number for that, that thing. You know what we can do is, we can go back to that. Let me finish the lesson and then I'll pause the video and then we'll go back. And if anybody hit this and calculator, what you were trying to follow me with your calculator and you didn't get this number, I will help you out with that, okay? But for right now, let's finish off this because some people probably had no problem with their calculator. All right, what do I do with this? I have to get the x's collected. So right now, again, I'm going to just rewrite this way. It's not any different, right? I just think of it as if you said you had 2x, you'd never write x2 because that would freak out people looking at algebra going, do you mean x squared? No, I mean x times 2. Well, then you write that like this and quit being a maniac. So I'm going to write that like this. This is log 3 of x, right? Next, or log of 3 times x is what I should say. Now I'm going to do the same thing here. So this is going to be 3 log 6x minus log 6. Once again, I have two expressions here, two terms that have an x in them. I have to collect them. And I have two terms that don't have an x in them, so they're just constants. So I'm going to collect those two. Then I'm going to factor out my x. And then, I'm getting kind of running out of room here, so I'm going to move over to here. Then I'm going to say that x equals, divide both sides of the equation by that bracket. It's negative the log of 6 minus the log of 2 all over the log of 3 minus 3 times the log of 6. Okay, so let's try it again. Person who didn't have their calculator give them the right answer last time, follow with me and make sure that you're doing this the same way I'm doing it. Okay, now if you're using an older calculator that doesn't have the same kind of logic as this calculator, like it's the kind of calculator where if you want to take the log of 10, you have to put 10 on the screen and then hit log, well then yeah, it's gonna look a little different than the way I'm doing it. But here's my attempt. Ready? I'm going to open a bracket for the numerator. I'm going to use my negative button. Negative log of 6. Close that bracket. Minus the log of 2. Close the bracket. That's this entire numerator, so close my numerator. That might be your problem, is you didn't close your numerator. Divide by, open a bracket for the denominator. The log of 3, close the bracket for that log, minus 3 times the log of 6. Close the bracket for that log, close the bracket for the denominator, and I think we get about 0.5. We do. 0.581. And a bunch of change. And there we go. Okay, I'm going to stop the lesson now because this video has been long enough. My God. If there's anybody still watching this and you're still awake, good for you. But there we go. Stop the recording.